Welcome to another Geography 215 math video. This math video is for Chapter 10. The learning objectives for this math video are to learn about cyclone bombs, to learn about upper air wind, and to learn about Chinook winds and snow cover. For question 1, take this statement found in your textbook on page 425. By convention, a rapidly intensifying extratropical cyclone is labeled a bomb if its central pressure drops at least 24 millibars in 24 hours. This should help you answer question 1. For question 2, take this problem. At the 500 millibar level, southwest steering winds are blowing at an average of 60 knots. A reasonable estimate of the forward motion of an extratropical cyclone embedded in the southwest flow is blank knots. Since the problem gives you 60 knots and 500 millibars is halfway up in the atmosphere, you are going to want to multiply 60 knots by 0.5 for half, which gives you 30 knots. Therefore, you would answer this problem 30 knots. For question 3, remember calculating temperatures and humidity of air parcels moving up and down in the atmosphere? Look back at the Chapter 6 math notes for this problem. Remember, in this problem the air is moving downward. Here is an example. At an initial temperature of negative 30 degrees Celsius, what is the temperature of the air parcel after it descends 4,000 meters? The rate of warming, air warms as it descends, is 9.8 degrees Celsius per 1,000 meters. Overall, the air descends 1,000 meters for 4 intervals. Therefore, multiply 4 times the rate of change, which is 9.8 degrees Celsius. Then, add the amount of change to the temperature that was given, which was negative 30 degrees Celsius. This gives you an answer of 9.2 degrees Celsius. For question 4, take this question. A Chinook wind can be catastrophic for snow cover. Assuming that the ground is covered by 35 centimeter depth of snow with a density of 0.1 gram per cubic centimeters at a uniform temperature of 0 degrees Celsius. How much heat energy in calories per square centimeter is required to melt all of the snow? Consider the column volume as 1 square centimeter by 35 centimeter depth. The latent heat of melting is 80 calories per gram. First, take 35 centimeters and multiply it by the column volume, which is 0.1 grams over centimeters cubed. One of the centimeters cancel from the centimeters cubed. Next, multiply that by 80 calories over grams. The grams will cancel, giving you 280 calories per square centimeter. It is square centimeter because one of the centimeters canceled at the beginning of the problem. For question 5, in blowing from the desert plateaus of Utah and Nevada towards the southwest, the Santa Ana winds undergo compressional warming at a rate of 9.8 degrees Celsius per 1,000 meters. If the initial air temperature is 10 degrees Celsius, how much descent is required for the air temperature to reach 48 degrees Celsius? So you're going to want to take the difference between the two temperatures. You want to subtract the larger one from the smaller one and divide that by the rate of change, which is 9.8 degrees Celsius. This gives you 3.877. You want to multiply that number by 1,000 meters because that is the rate of elevation change. This gives you 3,877 meters. Therefore, the answer to this problem is 3,877 meters. This ends the math video for Chapter 10. As always, if you have any questions, please feel free to ask. I hope all of you have a good week.